Do you know what happened in the movie Interstellar when the protagonist returned from his voyage and found that his daughter was even older than him? Well, I'll tell you how that happened. You all must be familiar with the name of the famous scientist Albert Einstein. He was the one who suggested that space and time are interrelated, where space is a three-dimensional world we live in. Both of them are together termed as four-dimensional space-time. Every object in the space-time curves it, and the heavier the object, the greater is the curve. This is what we call warping of space-time. Let's take the example of putting a ball on a bed sheet. When we stretch a bed sheet and put a ball on it, we'll observe that it creates a curve at that place, and the heavier the ball, the larger is the curve. Warping of space-time is the reason that the Earth revolves around the Sun, because mass of Earth is comparatively very small than that of the Sun. So the Sun creates a huge warp in the space-time, causing the Earth to eventually revolve around it. Now, the question is, why doesn't the Earth bump into the Sun? The answer is as simple as that. It's because the Earth has also deformed the space-time a little bit and hence maintains its balance. This states that a massive object warps the space-time more, so its gravity will be larger. Or in other words, greater the gravity, greater will be the warping of space-time. In the same way, a black hole is much more massive than the stars, and it has a very high gravity that even light can escape from there. Thus, it creates a huge warp in the space-time continuum. Let me explain you with the help of an example. Suppose we have to move in space-time from point A to point B and from point C to point D, where points A and B are in less warped region and points C and D are in the more warped region. You all know the simple equation that speed equals distance over time, where the speed of light is always the same, approximately equal to 300 million meters per second, which means that time is directly proportional to distance when speed is constant. So this indicates that in a more warped region of space-time, that is, in the area of strong gravity, the distance of traveling increases, and thus time being directly proportional to distance increases, hence showing that in the region of strong gravity, time slows down. This is what is called gravitational time dilation, and this is what happened in the movie Interstellar. The protagonist went to a planet which was very near to a black hole, where time slowed down for him, but not for the people who were on Earth, because they were in a weak gravity as compared to that of black hole. That's why when he returned, his daughter was older than him. So now I don't think you have any confusion about what gravitational time dilation is. And gravitational time dilation is also the reason why the Earth's core is approximately 2.5 years younger than its surface, because Earth's gravity decreases as you move away from the center of Earth. And yeah, this is also the reason why your head is slightly older than your feet.